In this lecture, we'll be looking at combustion reactions in fossil fuels. We'll look at what takes place during a combustion reaction, how a combustion reaction works, what fossil fuels are, where they come from, and how they're involved in combustion reactions. So the first question we have to ask ourselves, what is combustion? Generally, we would say combustion is a combination of some fuel source, oxygen, and a little bit of energy, usually in the form of heat or a spark or a flame. The result is the production of even more heat, more flame, a little bit of light, perhaps some sound. More specifically, combustion can occur with many different oxidizers, not just oxygen. Although usually those oxidizers are compounds that contain oxygen, and the oxygen in the compound is what's actually being involved. The result of combustion depends on the starting reactants. Whatever you burn is going to produce different products, but heat is always going to be one of the products. Combustion is a very energetic reaction. If we look at a very simple reaction, here we've got methane involved in a combustion reaction. Methane is the most simple hydrocarbon. Hydrocarbons are just compounds that are, as their name implies, hydrogen and carbon. Methane is the most simple of the hydrocarbons, and here we see methane combining with oxygen, and the result is the production of carbon dioxide and water. What we don't see here is that this reaction requires a little bit of heat to get it started, and we get a lot of heat out of it at the end. If you think about it, most combustion reactions usually involve a little heat to get them going. If you wanted to light a fire, if you wanted to burn a log to keep warm inside your house, you would have to use a match or a lighter to get that log burning. Once it starts, though, it's a chain reaction and it continues, and you end up getting more heat out of it than what you put into it. The reaction you see here is what's known as a complete combustion reaction. Here we've got just one compound, methane, burning to produce CO2 and water, and we don't have any other byproducts of this. But what can happen if you have incomplete combustion? For instance, in the case where you have a lot of different reactants or you don't have enough oxygen to combust everything. Well, the result is that you can produce a lot of different things. For instance, pure carbon. This is the major component of ash. Carbon monoxide, a very bad pollutant. Carbon dioxide, also a pollutant, and other carbon oxides. Now, we still get water out of it. That's going to be a pretty universal thing for the majority of combustion reactions. Incomplete combustion can produce a lot of different things, and this is just looking at hydrocarbons. If we have other compounds, then we, even through complete combustion, and definitely through incomplete combustion, we can get many varieties of compounds. Now the question is, where do we get hydrocarbons from? Hydrocarbons are from fossil fuels. Fossil fuels are not actually from dinosaurs like most people think. Fossil fuels are the result of a lot of really old dead plants sitting underground for a really, really long time under a lot of heat and a lot of pressure. And after millions, hundreds of millions of years, you end up with oils and gases and stuff like that. We can then drill down into the ground to retrieve those gases and oils. We can refine them and make our various types of oil and hydrocarbons out of it. Some of the most common hydrocarbons are actually commonplace in daily life. Stuff like butane, used for lighters, and propane, used for gas grills. Methane, what's known as natural gas, used for driving buses, running garbage trucks, and heating your home. The most common, though, is probably gasoline. The average American uses a lot of gasoline. But what the average American doesn't realize is that our gasoline isn't octane. Most people probably don't question what is gasoline really. They just look at the pump, they see an octane rating, and assume that has something to do with the composition of gasoline. And it does, but the reality is that our gasoline isn't just octane. There's actually a lot of stuff added to it. And what's added to gasoline can actually depend on the region where the gasoline is being made, the laws of the country where the gasoline is being made, and just what's available. If you were to look at the U.S., our Anti-pollution laws are a little bit different than a lot of other countries, so the additives we use in our gasoline to make the gas burn more cleanly, to make the engines run better, those additives are going to differ. Also, you look at the fact that the US, we have a lot of corn, which means we can make a lot of ethanol. You see that the US uses a lot more ethanol in our gasoline than other countries do. This is simply because it's a very cheap fuel source. There's some argument as to whether or not it actually burns cleaner, but still, it's cheaper, so it makes it a very simple process for us to add to our gasoline, and it becomes very efficient for us as a country. You look at other countries, they do it in other ways. Now, some of these other hydrocarbons that we're aware of, such as propane and methane and whatnot, these are common, but there's actually a lot of common hydrocarbons that we maybe are not aware of. Most people are aware that we use natural gas for heat, and some people know that that's methane, but what a lot of people don't know is that there's oil and lotion and cosmetics and your chapstick and your hair conditioner. There's all kinds of hydrocarbons in there. Lubricants for machines, paints, plastics, alcohols, and I'm not talking about ethanol, the type that you drink, I'm talking about more complex alcohols. These all come from fossil fuels. When fossil fuels are distilled, when they're cleaned up, when they're broken into their smaller parts, you end up with a lot of different products, and those products are used in all aspects of our daily lives. Now, looking again at incomplete combustion, if we take into account the fact that there are so many additives to gasoline, we start getting a lot more products than just carbon dioxide and water. Gasoline isn't a pure hydrocarbon, and combustion of gasoline is usually incomplete because our engines are not 100% efficient. Nitrogen and sulfur compounds occur naturally in fossil fuels, and it's very difficult to get rid of all of them. When we combust, nitrogen and sulfur compounds are some of the additives that are put in a gasoline, we get different products. Sulfur dioxide, nitrogen dioxide, nitric oxide, these can be produced from the sulfur and nitrogen along with a few others. They end up in the atmosphere, and they're greenhouse gases, and some of them can react with ozone to actually degrade the ozone layer. Volatile organic compounds and actually just raw hydrocarbons can be pumped into the air. Those are greenhouse gases as well. And then there's the fact that incomplete combustion produces ash. And a lot of that ash ends up being in the form of coarse particles and fine particles, and that ends up in the air. And then other compounds can be formed on top of that. It really just depends on what's in the fuel. Addition of oxidizers, these are special chemicals that act like oxygen, usually include oxygen. Addition of these oxidizers can drive the reaction towards completion, meaning that you end up with less of these byproducts, you end up with cleaner combustion. These different oxidizers also can lead to different energy production. Because they make the reaction more efficient, you get more energy out of it. And one good example of that is the addition of nitrous oxide, or NOS, to gasoline. We've seen this in the movies time and time again, where people just flip a little switch and some gas gets injected in the engine, and then boom, it takes off like a rocket ship. While it doesn't actually occur quite that dramatically, the idea is pretty simple. Nitrous oxide is a source of oxygen. When you add a little bit of heat to nitrous oxide, it breaks apart into nitrogen and oxygen. That oxygen is part of the combustion reaction. You get more complete combustion, which means you get more energy. Other oxidizers like hydrogen peroxide and ozone and a couple sulfur compounds also are really just sources of oxygen. So when we look at an overall combustion reaction and we say that combustion is really just fuel plus oxidizer leading to heat and products, those oxidizers typically are going to just be compounds that can form oxygen, and therefore you're really not getting a different combustion reaction. But those compounds may carry more oxygen and make oxygen more readily available than just regular air. In the next part of this lecture, we'll be looking at where the energy from the combustion reaction comes from, how that energy can be used in the human body, and why we don't burst into flames when the same kind of reaction is taking place in our body at all times.